amount of energy that is generated per unit weight. Okay, so per unit weight of fuel. So this concept is to be understood slightly. So here we can see that 1 gallon of petrol or diesel, it is going to require a very small amount of space, and as compared with the batteries, you can see 21 lithium ion batteries, they are going to be replaced. They are going to replace only 1 gallon of fuel. So the amount of energy is 135 megajoules, and in this case the purpose is served by 1 gallon over here, and in the same scenario we can see 21 lithium ion batteries, they are going to be required. So this is further shown over here as the amount of weight is 2.7 kg in one of the cases, and if you look at the battery scenario, then the weight is around 340 kg. So the difference is quite visible, and we can see that why IC engines they dominated. So this was one of the principal reasons why we can see there is domination. So specific energy, which is energy which is generated per unit amount of petroleum, diesel, or CNG, is much higher as compared with batteries. Okay, so that aspect definitely it has to be taken care of. Next, but despite that, there are different initiatives which have been taken from the side of government. We can see that there is a phase called as FAME 1 and FAME 2, where government has invested heavily for increasing the number of electric vehicles because of the lower emissions, obviously. So they are going to be utilizing batteries, and they will not be generating any type of. So that is one such advantage. Second, they are efficient. So the efficiency has subsequently increased. So with advent of time, we have seen that there are battery management systems. There are different types of batteries. So we can see that there are lithium polymer batteries, lithium ion batteries. So there are new chemistry. So people have tremendously worked, and they have now considerably developed a battery which can have a trade-off between the weight as well as the amount of energy which is generated. So as a thumb rule, I would like to tell all of you that in general, if we take 1 kilowatt hour, 1 kilowatt of battery, then the amount of cost that we are going to take into consideration is around 30,000. So that is one such thing that we should understand. And the number of kilometers is also in the range of 15 to 20. Okay, so if I'm taking an example of, let us say, any vehicle, today's vehicle from Tata or Maruti, we can say around 30 kilowatt hour, 30 kilowatt battery is there, and we can see 30 multiplied by 20. So they are working on different algorithms to provide us a range of around 300 to 400 kilometers on a single charge. At the same time, we can also see that there are various initiatives launched by various companies to provide warranty. So the main part is of electric vehicle is battery, and the cost of almost the one-fourth of the cost is reserved of the entire electric vehicle is reserved with the battery. So the companies, they are giving different types of schemes on, they are providing different types of advantages, like offering services to 2000 to 2 lakh kilometers or 8 years of service, whichever is early. So these kind of schemes, they are coming. So they are trying to establish a trade-off in this particular case. Then simple transmission and fewer moving parts. So that is second advantage why we are of electric vehicles. So when we talk about simpler transmission, we have to imagine the concepts of hub motors which are present on the two-wheelers. Then we can also have a drastic reduction in the gear mechanism, which is present in the IC engines, and that is a great advantage over here. So when we are reducing these transmission stages, we are directly increasing the efficiency of the overall system. So that is there. So as the transmission system is becoming simpler, that further provides us the advantage of fewer moving parts, because the moving parts, they are directly proportional to the the gear system, the mechanisms that are present in the gear system. So that advantage is definitely present. Then fuel choice, again, it's the next option. So EVs, they are having different types of varieties. So we can have a pure electric vehicle, then there is a hybrid electric vehicle which is going to have two both the components, IC engine as well as the electric component. Then we are having another combination of fuel cells as well as electric vehicles. So here we are converting the chemical energy into electrical energy, and we can see that the hybrid electric vehicle is not that popular because the amount of time which is required for processing of the chemical reaction is slightly higher. So people definitely they are working on that, and we can see improvement in that technology sooner or later. Next aspect that we need to talk about is oil energy independence. So when we are speaking about oil energy independence, we need to talk about fossil fuels over here. So continuously, am I audible? I think there is some noise coming in between. Hello, shall I continue? Does anyone have some kind of doubt? Am I audible properly? Anyone can just tell.
Yes, sir.
Okay. So the next aspect that we need to talk about is oil energy independence. So when we are speaking about oil energy independence, we are going to talk about the dependency on fossil fuels. So the fossil fuel dependency can be reduced as we are speaking about electric vehicles, and emissions they are going to improve with time. So as compared with pure IC engine based system, definitely the efficiency is quite higher in case of electric vehicles. And if we compare hybrid electric vehicles with IC engine based vehicles, still the emissions at the lower side, on the lower side. So these two advantages we can definitely see. So now, what is the main agenda in today's class? So we are going to talk about EVs and the topologies going to be considering. So if we talk about electric vehicles, we will be talking about conventional IC engine based vehicles, which will be followed by the hybrid types of vehicle, and finally we are going to talk about pure electric vehicles. So if you talk about conventional vehicles, we are going to see that the IC engine component is the dominating part. Okay, so fuel is going to be either petrol or diesel. So this fuel will be supplied to the IC engine, and the output of IC engine is given over to the transmission system, and the energy from transmission system is given or handed over to the wheels through the coupling mechanism, obviously. So this is the first component that we need to address. Next, if we talk about the hybrid electric vehicle system, we are having two components here. We can see that there is a battery component over here, and there is a second which is IC engine based component. So we are having both the components. One is IC engine based component, and the second is the electric component. So we can also categorize this vehicle as a system with electric component and a system with IC engine based component. So these two systems they are working. The next part which we need to understand over here is the connections that are being done. So the connection in case of hybrid vehicle, it can be done in series configuration manner, in series way. Then the second part that we need to understand, it is in parallel. And the third type of arrangement which is possible is both series as well as parallel. So both these approaches, they are definitely possible in case of hybrid electric vehicles. So if you talk about the IC engine based mechanism, we can see the working similar to the conventional IC engine based system. So the energy or the fuel energy is supplied to the engine. The IC engine is going to operate the geared transmission system, and the transmission is finally coupled with the wheels. So this is one approach. In the second part, we can see the electric component is present. So in the electric component, we can see that the output of battery is connected to the motor generator mechanism. So the device, it acts as a motor or generator depending on the power flow. Okay. So during the vehicle operation, we can see that the output from the battery is connected to the motor, and from the motor we are going to provide the output to the transmission system, and the transmission system is further connected to the wheels. Okay. Then if you see, this is a bidirectional power flow. So this bidirectional power flow comes during the braking. So during braking, we are going to consider the regenerative mechanism, regenerative action would be there. So when braking is into action, at that time the energy from the transmission system is fed back to the batteries through this generator. So in that particular case, the electric machine, it acts as a generator. So you can see that this is a bidirectional power flow which is represented over here. So this was about the hybrid electric vehicles. The next part, as we can see, is a pure electric vehicle. So if we talk about pure electric vehicle, we see only the battery, then there is electric machine, and then we have a transmission system. So here we can definitely see that the battery mechanism output is provided to the motor generator system, and from the motor generator system we can have the connection to the transmission system, which is further connected to the wheels. So this is a pure electric vehicle, and we can, as we said, this is the cleanest source. The emissions are least in this pure electric vehicle. So now we are going to understand the topologies one by one. When we discuss about pure electric vehicle, we see that it is having a power source. Okay, so we are going to have a power source over here. Okay, so the power source of the EV charger, which is also referred as EVSC. So EVSC, I guess you might have been gone through this terminology. That is electric vehicle supply equipment. Okay, so whenever we wish to charge the electric vehicle battery, we need to use the electric vehicle supply equipment, and there are DC chargers or DC chargers depending on the manufacturer. We are going to have AC or DC chargers. So the electric vehicle supply equipment would be there. So the outlet, so the power outlet of electric vehicle would be connected to the EVSC, and then from the power outlet we can see that the electric vehicle battery would be charged. So you can see that the battery is present at this particular location, and the energy storage charging system, basically it comprises of a DC to DC converter. Okay, so this DC to DC converter is present. At the same time, we are also going to have a controlled power converter. Okay, so we are going to have these two components sitting over here. So the power outlet is going to be connected to this controlled power converter, and when we talk about controlled power converter, it can be either in rectifier mode or it can be in inverter mode. So we are going to have both this configuration. Okay, so we can have both this configuration. So whenever we want to charge the battery, at that particular time, we are going to use this particular power converter as a controlled rectifier. We are going to make use of this as a controlled rectifier. So we are going to have the AC power converted into DC, and then the converted DC will be further applied. It will be further applied to a DC-DC converter, which is going to generate a voltage which will be suitable for the ratings of battery. In order to cater to the needs of battery, we are going to have this particular source. So this is going to be there. So we can definitely work on that. Okay, so this is one such approach. And then when we are considering the operation of motor, during the operation of motor, we are having another converter. Which is going to have the perform the conversion, which is going to perform the conversion from DC to AC. Okay, so this is again a power converter. We are not going to specifically call it as an inverter, but it will be a bidirectional power converter. It can be again configured as an inverter or rectifier. So during the vehicular operation, this will be configured. This power converter would be configured as an inverter. So the DC power would be converted into AC, and the output of inverter is given to the traction motor. So this traction motor is going to generate the tractive force. Okay, so this is going to generate the tractive force. I hope you are aware of what exactly is tractive force. It's the total pulling force which is going to be generated. It is going to be generated by the vehicle in order to overcome all the opposing forces, Now these opposing forces, there are various mathematical expressions. We are having the opposing forces like aerodynamic drag is there, then there is a hill climb resistance is there. Next, we are also having the rolling resistance. So there are different components which we can, discuss if time permits, obviously. But the aerodynamic drag, hill climb, rolling resistance, as well as the thrust or the final output force, which is to be calculated as per the speed requirements which are given by the user. So they are also to be included in the tractive force. So this is tractive force is generated with the help of this inverter and drive mechanism. So inverter drive mechanism, it is going to be operated by different control strategies. It may be field rate control, or it may be any BLDC control strategy or PMSN control strategy. It depends on which type of motor is being used by the manufacturer. So this is something that we should understand. The next of the next type of converter that we need to understand is a series hybrid electric vehicle. Okay, so in the previous part we have considered a pure electric vehicle. So in case of pure electric vehicle, we had only the electrical component. So here only the electric component is present. Okay, so if we consider the series hybrid electric vehicle, so when we are talking about hybrid, then it will be comprising the IC engine part as well as the electric components. So both these components, they are going to be present over here. Okay, and the word series basically tells us about the type of connection. Okay, the type of connection which is present in between the IC engine component and the electric component. So the manner in which these two components they are connected defines whether it is going to be a series connection or parallel connection. So here we need to understand that there is a series connection in between the electric component and the IC engine based component. So this is something which we need to understand, how exactly the components they are connected in the series. Okay, so we'll understand one by one. So if you see the mechanical components, we can definitely see that the IC combustion engine is present over here. So this typically, this typical component, it can be earmarked as a mechanical component, while the remaining component, okay, so generator is also going to be there. And here, if you see in the block diagram, we can have the electric component. So here we can have the electric component. Okay, so the fuel, okay, so the IC combustion engine, it will be present definitely, and it will be supplied with the fossil fuel. So here we are going to provide input as fossil fuels. So these fossil fuels are going to be provided to the IC combustion engine, and it will be generating the energy which will be connected to the generators. So this is something that we need to understand. Fossil fuel energy is provided to generator, and from the generator we are providing output to the rectifier based system, and further again we can see it is having connection with the inverter and traction motor based system. So this is something that we need to understand. And the second component, which we can clearly see, is the IC engine based, electric component based system. So this is the plug component, which was previously evident over here. So if you see this diagram, the plug component which is shown over here. Here again we can see that the connection from electric vehicle supply equipment would be brought over and connected to this particular point. Then the output is from the EDAC would be given to the energy storage system. Again, this is going to be comprising of the two components as we have rightly discussed. So energy storage system. And just a minute, if anyone is having doubt, you can raise it to me. If someone is Yuvraj Dongle, so if he is having any issue, then he can raise it right away. He's typing something at random. So, do you have anything to say, or shall I continue? Okay. So here, the electric vehicle supply equipment output is given to the plug, and again we are having energy storage charging system. So this energy storage charging system, as we have discussed, it is going to be comprised of power converter, same thing. So it is going to be comprised of power converter plus a DC-DC converter. So these two components, they would be present, and the output, the DC output which will be obtained over here, will be used to charge the battery. So the battery would be charged, okay, and it will be fed to the inverter. So the flow of power, okay, now we will, I'll use a different color so that you can understand it clearly. So during the vehicle charging, the power would be flowing in this particular way. So this is how the power would be flowing, okay, during vehicle charging. Next, I'll use again a different color. I can make use of some another color. So during operation of vehicle, we can see that the power would be flowing from the battery, okay, to this inverter, and from inverter it would be flowing through the drive system, So the drive system, again, it's comprised of power converter, and this is the machine. Okay, so we can have this machine. So it can be again BLDC, PMSM, or induction motor. So either of them that can be used. So during, when the vehicle is being charged, at that time this component number 1 and 2 and 3, so this three components, they are operational, okay. And when the vehicle will be in motion, when the vehicle will be operation, at that time we can say that the components, 3 4 5, okay, 2 3 4 5, they would be in the motion, they will be in action. So this is something we need to understand. Okay, so when exactly is the role of IC engine coming into picture? So this is something that we need to understand. So series hybrid electric vehicle. So now here we need to understand that whenever the battery is about to get discharged, okay, I'll repeat my statement again. So whenever the battery is about to get discharged, we can use the energy from the IC engine. We can be in a position to use energy from the IC engine, and that can be used to charge the battery, okay, and this energy, it can be used to charge the battery. So this is important, okay, so this is very, very important. So the energy from the battery, okay, if it is about to get discharged, then we can charge the battery by using the IC engine, okay. So we can charge the battery using this IC engine. So this is something that we need to understand. So if you carefully understand what exactly we are doing over here is, we are making use of IC engine component only when the energy from battery is use getting discharged. So the IC engine will be only used for charging the battery. Okay, so for operation of electric vehicle, only the main component which is visible over here is the EV vehicle. Okay, so this series, why it is called as series? Because the power source which is present is only used to charge the battery, and the main component which is connected to the traction system. Okay, it is the electric component. So if you see the transmission system, it is connected to the electric components. Okay, it is from the inverter to the motor and then to this system. Okay, so this is something which we need to understand. Okay, now if you talk about parallel hybrid system, the parallel hybrid system, then the scenario is going to change entirely. Then the scenario is going to change entirely. So you can see that there are here also, since this is a hybrid system, there will be two components. We are going to have the mechanical system and we are going to have the electric component. So both these components, they are going to be present. Okay. So we are going to have the mechanical component as well as we are going to have the electric component. So that is fine. Okay, but here both of the components, they are connected to the system. That is why we are going to say that they are in parallel. So you can see that the transmission system is having a parallel connection. So we can see that the mechanical components, they are also connected to the transmission system, and if you see over here, then the electrical components, they are also connected to the transmission system. Okay, while if you just go back and see the previous slide, we can see that there is only electric component. The mechanical component is only used for charging the battery. So that is something we need to distinguish in between both the series as well as hybrid type of EVs. Okay, so this was the part. So from IC engine, we are going to have a torque coupler, and from torque coupler, it will be connected to transmission system, and from transmission system, we can have the power sent to the wheels. So this is one option when we are using the mechanical component. In the second component, when we are expecting energy to flow through the electrical domain, when we want to make the energy flow through the electric domain, we can see that the energy storage charging system is present. Then the battery the battery would be charged through the EVAC, obviously. So from EVAC, there would be power flowing through the plug and then to this DC-DC converter and a power converter. Okay, so the same components, they would be present as it is over here. Okay, so during charging of vehicle, it would be working in rectifier mode. Okay, so this is how the power would be flowing, and the battery be ensuring the proper voltage which is connected to. I guess there are again some doubts. So if there are any doubts, you can raise it right away. You can unmute yourself and you can ask me, not an issue. So if you see this parallel configuration, we are talking about both these components. So the mechanical component and the electric component. So let us discuss them once again. So we do have these power flows. As I said, this is the mechanical part and this is the electric part. So here we can rightly have a comparison straight away. So they are connected in parallel, and therefore we can say this is a parallel hybrid electric vehicle type of configuration. So this is something we need to understand over here. And during regenerative braking, we can see there would be a bidirectional power flow, and the bidirectional, in that power flow, we can see the power would be flowing through the transmission, then to the traction motor. Here the motor would be acting as a generator when there is regenerative mechanism, and then to this power converter, which would be you know working as a rectifier. So during regenerative action, it would be working in fourth quadrant, and it would be working as a controlled rectifier and not as an inverter. So this is something we can clearly identify. Okay, the same thing is definitely relatable with this series type as well. So in during the regenerative mechanism, we need to understand the flow of power. The flow of power would be in this direction. Okay, so the flow of power would be from the transmission to the control rectifier. Okay, so it would be working as a control rectifier during that scenario. Okay, and then this part would be bypassed, and directly it would be connected. The battery would be charged. So this is something we can understand. Okay, so we have talked about three configurations. The next part that we need to understand is a series parallel hybrid configuration. So we can understand about series parallel hybrid configuration. Okay, so this is again a categorization of hybrid electric vehicles. So if you talk about hybrid electric vehicles, it will again have mechanical as well as electric component. And as the name suggests, it is a series parallel. So we can have both the configurations possible. Okay, so we can have a series configuration, or we can have a parallel configuration possible. So both the configurations, they are possible in this particular case. Okay, so if you take into consideration the series operation, if you take into consideration series operation, this power split device is used additionally. Okay, so the only thing that we need to understand in case of series parallel hybrid electric vehicle is that there would be a power split device. Okay, and this power split device, it is going to ensure proper arrangements of